Welcome to In the Mix, the show that puts masonry in the spotlight, block by block, brick by brick. I'm your host, Adam Hutchinson, Executive Director, Professional Engineer, Industry Advocate, and believer in the power of resilient building design. Every week, I sit down with architects, engineers, contractors, and building owners to break down how masonry makes our communities stronger, safer, and more resilient. We're here to share stories, tackle the tough questions, and help you see what's possible when we build better together. Let's get in the mix.
So what does it take to build safer, longer-lasting, adhered masonry systems in one of the most demanding climates and seismic regions in North America? On today's episode of In the Mix, I sit down with John Gallup, a longtime Laticrete representative who's now with HydroBlok, to break down the evolution of adhered veneer masonry, the science behind modern installation systems, and the code changes reshaping the industry. From polymer-modified mortars and waterproofing assemblies to shake table testing at Portland State University, John shares how innovation, testing, and collaboration is helping architects, contractors, and engineers build smarter and more sustainably. This conversation dives deep into the technical side of masonry systems while also exploring the real-world challenges of labor, climate, moisture management, and long-term durability in the Pacific Northwest.
So first, tell us about yourself, what you do in Laticrete, how you help the Northwest.
Well, Adam, first of all, thank you so much for having me today, and thanks to the Masonry Institute of Washington and the Northwest Cement Masons Association for hosting. I think this is a great endeavor and really is a key part of doing advocacy for our industry, which is near and dear to my heart, as I'm sure it is yours. First off, a little bit about Laticrete. And it seems like the farther west you go in the country, in the U.S., the more the A in Laticrete gets shortened. So You'll hear Laticrete, the pronunciation Laticrete, seemingly in the west. And the farther east you go, it's Laticrete.
Oh, really?
Yeah. So the word itself is an amalgamation of latex and Crete. Crete mix, Portland cement-based Crete mix. Henry Rothberg, our founder, who founded the company literally in 1956, developed the first vestiges of a latex Portland setting mortar at the time used for tile. And since then, fast forward decades, the company has grown and evolved to where we don't just go to market with setting materials for thin tile assemblies installed with a latex Portland cement modified thin set, but we have a whole range of grouting materials. We have a whole range of waterproofing and crack isolation membranes for ceramic and natural stone tile assemblies, in addition to some specialty products like self-leveling underlayments, hydraulic cement underlayments in the tile and flooring industry.
This is all encompassing products, not just admixtures for the producers or for cement manufacturers, right?
That's correct.
Or concrete manufacturers.
That's correct. And in the tile channel in construction division 9, it's a rather sophisticated product portfolio.
Right.
We identified, transitioning over to masonry for a moment, we really identified an opportunity and really a need for taking what we know about tile installation in regards to the benefit of polymer modified and latex Portland modified so-called adhesive mortars, cementitious, cement-based adhesive mortars, and taking that technology into masonry, and specifically adhered veneer masonry, things like thin brick, cultured stone, manufactured stone, thin natural stone assemblies and exterior conditions that really touch Division 4 in masonry, and taking that technology and that approach in what we call at Laticrete, our masonry veneer installation system, or MVIS system.
Yep.
It's been very effective. We have been honored to partner on a number of really high-profile commercial projects in the Pacific Northwest with companies like Mutual Materials, with Eldorado Stone, Mutual with their Slim Brick line, and being an installation materials partner, we also provide within that portfolio, as we do our tile and stone products, a comprehensive systems warranty. So the quality assurances are there in place when choosing Laticrete for your tile and stone installation systems and your thin veneer masonry applications.
So that's a lot about Laticrete. So what about John? How did you get into this industry? What do you do? Are you reaching out to architects? Are you engineering focused? What do you do mostly for Laticrete?
Mostly, I tend to be a little bit of a one-man band, which is, I feel, a really good thing because I can take a project as a manufacturer's representative with technical resources and the war chest of technical resources from Laticrete. I can take a project from development and design with the architect all the way through to distribution to the contractor. In regard to what I do, in answer to your question, my title is technical sales representative. It's multifaceted. Again, I have a lot of engagement in the architectural channel. I actually serve on a committee for the Portland chapter of the Construction Specifications Institute. My primary real estate, my primary region is the state of Oregon. I also have some responsibilities in Southwest Washington. And I also have engagement at the architectural level in Seattle and Puget Sound with AIA, with Construction Specifications Institute in Puget Sound. We participate in their ProSpec event every year, which is their vendor expo and trade show and keynote speaker discussion. And so we participate at that level. My primary focus is really with our distributor partners. And we at Laticrete are really honored to have a number of really high-level distribution partners and contractors, both in the commercial and residential channel. So my primary responsibility as technical sales rep is engagement at the architectural, the distributor, and the dealer and contractor level for both tile and stone and masonry veneer installation systems.
Right. It's all Laticrete products, right? Or it's just focused on masonry products?
100% Laticrete products, but focused on, in terms of product segments, Division 9 tile and stone installation systems and Division 4 in masonry, and specifically adhered veneer masonry systems.
So we worked together, was it 2021, putting in the code change proposal to require an ANSI A118.4 polymer-modified mortar requirement for adhered veneers in Washington. That was based on language that was already adopted or being worked on at TMS that had been approved. And Washington was the first state to adopt that language.
Correct.
Tell me a little bit about that work that you did with Tom Young and the research that you had to do before that to get it into the code.
Well, this is where I'll say that a lot of the heavy lifting at the 10,000 foot level was done by our Associate Director of Masonry Veneers at Laticrete, Mr. Bob Duke. Okay. And Bob had a lot of engagement with TMS at the national level. Regionally, locally, your predecessor, our dear friend and colleague Tom Young, and I collaborated at pretty deep level. Tom had a lot of inquiries for me as a representative of a latex Portland polymer-modified adhesive mortar product that really is a good fit for adhered veneer masonry. To give you a little bit of background, we would see typical Type S, Type N mortars, which do a first-class job of both providing both joining and separating full unit brick and block as a preferred mortar. Here behind us here in our archway here, we have some full dimension masonry that's set with Type S mortar.
It looks like it. It's actually a thin set.
How about that?
Yeah.
Another incremental opportunity for a thin set mortar. That typically is the function of a Type S mortar, to both join and separate units of full brick and block.
And when you say to join and separate, what we're talking about is bonding the two units together so that cracks don't appear horizontally or vertically in the bed or head joints, but also giving us a separation so that when we push down on it, there's enough aggregate there, there's enough strength to the mortar that it doesn't just squish out.
Exactly.
So we can get our 3/8 or our 1/2 inch joint that we need.
Exactly. These units are separated. These two brick units are separated by this layer of mortar, but they're also joined.
Right.
Okay. Within this context, a Type S mortar functions very well. What we've discovered is when you transition away from full brick and block assemblies to thin veneer assemblies,
Right.
a Type S, a standard commodity Type S, Type N mortar really doesn't function as an adhesive bond coat. You need shear bond value. That's where
Instead of just tension bond.
tension bond, you
Right.
need shear bond. Tile, this goes back to our humble beginnings and really as Laticrete's legacy as a tile and stone installation systems manufacturer. Borrowing from the success of tile installation, we identified a critical need really for a formula that meets the American National Standards Institute A118.4, which is the material section for latex Portland cementitious mortars. There have since been some enhancements to that to include a new section, relatively new section called ANSI 118.15, which is a high performance mortar, which we talked about shear bond, will give you a 400 psi shear bond for things like not only tile, but also adhered veneer masonry.
And the real reason why this is important to have is a lot of these times we're trying to build these adhered veneers to reduce the weight of the building. We're trying to go higher up on the building with this veneer. And sometimes we have soffits and they want the brick to come down, look like it's a full straight brick row that goes down underneath the soffit even.
Absolutely. And this is where I'll take a moment to talk about one project of many that we were involved with in the Pacific Northwest. And that's the Louisa Flowers apartment building in Portland, in the Lloyd Center of Portland, Oregon. It was completed in 2019. It is currently the tallest building on the North American West Coast to take a full wrap, a full skin of adhered veneer masonry, in this case mutual materials slim brick, with a complete Laticrete masonry veneer system to the tune of 12 stories. So yes, we are attempting to provide the same functionality, the same curb appeal with adhered veneer masonry, in this case specifically thin brick, as full unit masonry, and we achieved that very successfully with the Laticrete MVIS system, the EMBA system as we lovingly call it at Laticrete, and mutual materials slim brick.
So let's go into the technical a little bit about that. So describe the makeup of that wall system from the exterior to an interior if you have a cement board backer.
Sure. And we see assemblies in the Pacific Northwest that are predicated on a cementitious backer board as the substrate, at least commercially, the overwhelming choice for the assembly. One little aside before I get into the details of the assembly, going back to Type S mortar, walk up to any grocery store that has column work, which is adhered veneer masonry, typically manufactured stone, and where the shopping carts have rammed into the first couple of courses at the base, they've come off. And that's because we have a substandard, inefficient adhesive bond coat, oftentimes in the form of Type S mortar, intended as that bond coat, and it fails. We also are in a relatively extreme weather region here climatically, where everything in the Pacific Northwest seems to be wet, dry, and then hot, cold in a relatively short amount of time, which underscores the need for a polymer-modified cementitious mortar that meets the ANSI standards.
Right.
Going back to the assembly, what we see really it's ascending to be the overwhelming choice for the complete assembly is we will see structural sheathing, skinned with a WRB or weather-resistant barrier, and then typically in lieu of applying our cement backer board directly to the field of that WRB, we'll see what we call a furred-out wall assembly, where we have hat channels or an engineered girt system, Z-girt system, placed over the structural sheathing in WRB, and then that creates a drainage cavity where we then apply our cement backer board.
And that also gives them an area to put insulation if they need to.
Exactly. So we see a lot of outboard, a lot of mineral wool-based outboard insulation, which has great R value. And creating that cavity provides a gap not only for outboard insulation, but also a free passageway for moisture to escape if it gets trapped behind the assembly. Once we've installed our cementitious backer board mechanically, we then skin that with a fluid applied membrane. Going back to the tile industry has had fluid applied membranes that meet the ANSI, American National Standard 118.10 material section for a number of years now. And that technology, that formulation is a really good fit to provide a fluid applied system of what we call, my friend and colleague Bob Duke calls, bulk water management.
Okay.
It's like the final touch of that bulk water management system, where we now have a protective layer on the front face of the cement board, protecting the seams, the field seams in the cement board assembly, the fastener punctures, because we are attaching this mechanically with poly-coated backer board screws.
Right.
And then we have a full field of fluid applied waterproofing, which also serves as a block against efflorescence weeping out onto the face of thin veneer masonry.
Right.
This also provides a layer of crack isolation for the assembly as well. And that is all referenced, I will say, I'll just sneak back here. This is all outlined in the adhered veneer section of the Masonry Systems Guide Pacific Northwest edition.
So, and you can go to masonrymix.com and we will have that link available for everybody to download. So that's a great systems guide. I know Laticrete did a lot with it. We had a lot of really good industry representatives and scientists working on putting that together.
Sure.
And as far as I know, everybody references, not just in the Northwest, but everywhere in the US, they have either made a new version based off of the Northwest Systems Guide, or just say, no, we just reference the Northwest Systems Guide.
It really has become a basis of design for the country in no small part. And I remember back years ago when I played for another team where I was sitting in those committee meetings with RDH engineers and with the Masonry Institute of Washington, and we were really figuring things out. And all of that information made its way into our systems guide, and there are entries in there not only for the assembly, but also things like movement and expansion joint requirements, which are mission critical, particularly in a climate like the Pacific Northwest, where again, you have thermal movement, hot, cold, wet, dry conditions constantly that really benefit the assembly. And the movement joint types, the materials used, and the frequencies for movement joints for adhered veneer masonry are all outlined in the National Masonry Systems Guide Pacific Northwest edition.
Yeah. So let's get back to the assembly. So we have our structural sheathing, a WRB, a Z-girt system or hat channel system to give us a cavity, insulation inside that cavity, the cement backer board screwed on or mechanically fastened to the Z-girt assembly. And then what was the film on the outside of that cement board?
Yeah, the film is a waterproofing membrane that complies with the ANSI, American National Standards Institute, A118.10 material section. And we see that ANSI 118.10 waterproofing membranes are very prevalent in the tile industry in Division 9, and they also serve adhered veneer masonry assemblies very well. So as an architect or a specifier, you're looking for a material that complies with that ANSI 118.10 standard to apply over cement backer board and adhered veneer finishes.
And then after that, we put on our scratch coat and our setting bed, or do we just go straight to the setting bed?
Here's the beauty of a thin adhesive, polymer-modified adhesive mortar is there's no scratch coat required over cement board. We can, in the spirit of efficiency, once we've applied that fluid applied membrane, install directly to that face with an ANSI 118.4, 118.15 high performance adhesive mortar and enjoy the warranty, the quality assurance from the system's manufacturer. In my case, obviously, with Laticrete, we have done countless installations where we direct apply the adhered veneer masonry with no scratch coat requirement directly to the face of the cement board. A little bit more on that because I think it's important. In today's matrix, labor is expensive.
Absolutely.
And by comparison, technology, even though we're seemingly charging a great deal for units of our installation materials, but the chemistry and the technology and the engineering in these materials is relatively small in comparison to the labor. So the value proposition is really if we can mitigate labor in terms of a scratch coat.
Right.
If we don't have to, as an installer, mechanically attach the 2.5 pound square yard diamond middle lath, if we don't have to trowel that scratch coat, that's our value proposition for the engineered mortar applied in a direct fashion to where we back trowel
Yep.
our piece of thin brick or our manufactured stone and provide a back trowel coat, comb our mortar with a notch trowel in a tile fashion and set that material with no last scratch coat requirement. That's really the value proposition for the entire system, and particularly a polymer-modified cementitious adhesive mortar.
So you're notch troweling the bed of mortar that's on the wall.
Correct.
And then are you smooth troweling onto the unit that you're placing, or are you also notching that?
No, typically you're smooth troweling the unit, typically, and then installing into that layer that's been troweled with a notch trowel. And in the words of Abraham Lincoln, when they asked him, how long does a leg have to be? Well, long enough to reach the ground. The trowel notch, it's kind of a cute analogy I like to use, but the trowel notch size is contingent upon the size of the material. So standard rule of thumb, the bigger the unit, the adhered veneer masonry unit, the more volume of adhesive bond coat we need.
Yeah, so
the larger the trowel notch.
if you have a 2 5/8 unit that's a natural stone or a manufactured stone, you're adhering to a wall, then you're going to have a pretty thick trowel joint.
You're going to have a far more robust trowel notch, for sure.
Compared to thin masonry veneer, brick veneer, face shell, that is not very thick at all.
And which, by the way, so many of the thin brick units are made out of mica clay, which you and I both know is fairly lightweight. And when you have a redacted unit size, like a piece of thin brick, we see a lot of thin brick installed with a 1/4 x 1/4 square notch trowel with a light skim coat as a back trowel, and you achieve 100% coverage that way. Going back to the tile industry for a moment, the Tile Council of North America in their handbook actually calls out coverage requirements for adhered veneer and thin set applications for exteriors of 95% coverage minimums.
That makes sense.
So we really want to see 100%, but 95% coverage is the minimum. If we're in the Pacific Northwest and heaven forbid a grout joint fails or a sealant joint fails and we get moisture into that void in that bond coat and it hides into that void, it's going to freeze. And we all know what happens when water freezes, it expands and it's going to shatter that bond. And
we have so many freeze thaw cycles up here that it just makes sense that we want to make sure no water intrudes, or if it does, it has a way to get out. Right?
Absolutely.
So
exactly.
Yeah, no,
and that's ensured by that 100% full coverage bond coat.
Right. Well, that's really cool. What about testing and research? What have you done with Portland State University to help make people comfortable in this high seismic region to use a lick and stick brick?
It's a great question. We have had, and this is a really valuable update in our industry. When did we conclude this? A couple of years ago now.
It was 2022 or 23, somewhere in there.
Correct. We concluded towards the end of 2023 a comprehensive, for the first time in adhered veneer, seismic testing initiative. Right. And I really have to credit my friend and colleague, Sean Scott, who's a building envelope consultant in Portland. He was kind of the instigator, the quarterback on this whole endeavor. And he had a lot of questions and really discomfort about putting adhered veneer masonry on projects like multifamily and big commercial projects where we're putting, adhered veneers 120 feet in the air.
Just way up there.
And as he started to do his due diligence, he realized that there were no standards for seismic regions like the Pacific Northwest. So we endeavored with a number of stakeholders, including Laticrete, including the Masonry Institute of Washington, including Mutual Materials.
And the Northwest Concrete Masonry Association.
And the NWCMA, absolutely, in funding this whole endeavor, which started in 2019.
We had a little setback there in 2020. So did everybody else.
Set to go at the beginning of 2020. The beginning of 2020, and the darndest thing happened. We had a pandemic and it really pushed us back. So the whole initiative took a lot longer than anybody anticipated. The Science and Engineering School at Portland State University, where we concluded this because they are one of two education facilities, high learning education facilities on the West Coast that have the shake table equipment that's required for this endeavor.
Right.
And long story short is we tested 6 specimens. We did some framed walls. We did framed walls with cement backerboard. We did framed walls with a typical lath scratch system.
Right.
We had some steel framing, some wood framing, and every single specimen passed our code initiative to the point that I remember being at Portland State during one of the tests with Sean after we passed the 14 cycle code initiative. And we kind of looked at each other and said, well, we rented the use of the hall and we simulated major seismic conditions and nothing came off. No adhered veneer masonry. The points of failure, if any, were mechanically between the framing and the cement board or at the window treatments. So we were very pleased with the whole initiative, and the test results are available through MIW and NWCMA.
Absolutely. And one of the really cool things about that study is when we talk about failures in engineering, it's a life safety thing, right? So we're not talking about not only the whole unit falling off, even if small portions are falling off, it would be considered a failure if they were big enough.
Correct.
So in the study, my recollection of the study is that the pieces that did come off are little tiny specks from the corners of the units, and that's it.
I still have, after the first specimen, I still have the piece of facial thin brick that flaked off. It's in my desk. I should have brought it. And it was far less than a gram worth of material.
Right.
Not enough to cause any real personal damage at all.
It was small enough that even at terminal velocity, it might feel like something pooped on you.
Right.
Right.
Yeah. And actually, Sean did some testing on that in field. And I don't know exactly what the sensation was, but it was far less than a condition that would have caused
Right.
any
It's not a life
semblance.
safety issue at that
It
point.
wasn't a life safety issue. It wouldn't have caused any semblance of personal injury.
So one of the questions that I like to ask is, where do you see the industry going from here?
In terms of products, I think the categories will stay relatively the same. I think you'll see enhancements to products within those categories. And by categories, I mean waterproofing and crack isolation membranes, setting mortars and tuck mortars, pointing mortars / grouting materials in the tile industry, to transition to be more efficient, to control cure times, to have more rapid cure times, to be more stable in lower conditions, lower temperature conditions, I should say, in the installation process. One of the challenges that we have in the Pacific Northwest, being a northern climate in the U.S., is installing anywhere from, say, mid-October into March or even April because of freeze thaw and because of lower temperatures.
Right.
Typically, cementitious latex Portland dry polymer modified setting mortars that meet that 118.4 standard, they like somewhere between, in our case, 40 degrees Fahrenheit and 90 degrees Fahrenheit.
Right.
I see products becoming more efficient to dip down and be able to cure in temperatures below that 40 degree threshold.
I think that's an interesting technology change that's going to need to happen just as well above 90 degrees. So where, we can add a little bit more water if we need to
Sure.
in certain applications of typical masonry construction.
Yeah,
But if you get too hot, things cure too fast.
absolutely.
If
And they'll
it's too
flash on
cold,
you.
then it doesn't cure at all.
Right.
So I think that's a great opportunity for technology to work on. I don't know if it's the Portland cement side or what, but we can definitely see some technological advancements there.
There is a whole community of chemists and product engineers that figure that out. How we get there and achieve those goals is way above my pay grade.
Absolutely.
But I know at Laticrete, we are in really good hands in regards to product formulations. I can't speak about it, but we just had a new product update this past Friday. And
Oh, cool.
believe me, as sure as I'm sitting here, there are going to be some exciting new updates, product updates in the very near future from
That's
Laticrete.
awesome. We have your system, the Laticrete system, the MVIS system. Face brick is the full bed brick that we normally use with a typical mortar. We've got our thin face shell, thin brick with your system. What are some strengths and weaknesses that you see between the two different systems for architects to really think about when they're designing? Is it more about keeping water from penetrating through the system and then making sure that they have a good drainage layer behind it? Is it challenges from the environmental rain that we get a lot here? What do you see as the biggest strength and the largest weakness that we have to overcome
in adhered veneer masonry?
Yeah.
I'll start with the strengths. Because we are a thin, much lighter weight assembly, we typically don't require the substructure that full brick and block does in regards to red steel, lintels, brick ledge. We don't need to rest an adhered veneer masonry assembly on a brick ledge, so we can forego a lot of concrete and concrete installation with that assembly. As far as any weaknesses, or I'll call them challenges in regards to full brick and block, I have to tell you that a lot of what we see in the manufactured stone segment is quote unquote dry stack, where you don't have a pointing mortar required. You're simply stacking the units.
Just unit to unit. They're touching. You can't see any of these joints, right?
Correct. Contractors will tell you, as they've told me, we love thin veneer masonry, but one of the issues is when we install the piece of adhered veneer with the appropriate polymer-modified adhesive cementitious mortar, and then we have to come back and fill the joints if it's thin brick. Yeah. It's a two-step process. So if there's any challenge there, and this is maybe where some of the new product updates will make the system more efficient, but with full brick and block, you parge the mortar, you set, you level, you strike the joint, and you're done.
Right.
Okay. That to me is the biggest challenge with
it's the mobilization twice of two different crews, really.
Correct.
Because you might have your tile setters and your masons coming in and doing the setting bed mortar and setting the units, but then they have another crew coming in and pointing it and sealing it.
One other thing as we're talking here that comes to mind is mobilizing with cement backer board. Because typically cement backer board is in a 4-foot by 8-foot panel, and it's going on a 16-inch stud frequency. To align with that stud frequency, it's a 4x8 panel. Outside of the fact that cement board can be heavy, the estimators, and there is equipment available to provide these efficiencies now, but the estimators need to understand as they're bidding the project, you're not going to mobilize 4x8 sheets of cement backer board in standard scaffolding. And there's going to have to be some considerations taken in place to mobilize the material. So it can be done right. When you have a project estimator that's done adhered veneer masonry on your podcast, maybe you can dive into that topic and they can provide you the nuances. But I know that's one consideration of contractors when installing cement backer board based adhered veneer assemblies.
Absolutely. Well, John, do you have any other closing comments or aspirations that you want the masonry industry to know, the architects and engineers to know?
I just really hope that we continue to embrace the right products and the right assemblies that are available out there. We used to have dirt roads in this country. And
still got them some places.
I actually live on a gravel road, believe it or not. But there are better products out there that may seem more expensive, but they're more sustainable. And that old adage, there's never enough time to do it right and always seemingly enough time to do it over, really makes the case for using the right products and the right applications and embracing technology and chemistry and the inherent efficiencies of new contemporary products for adhered veneer masonry.
Yeah, and we always like to say the most sustainable building is the one that's already built. So if you can build it once and it can last 100 years, then that's going to be more sustainable than building it again in 50 years.
Tear out and replacement is not green.
No, it's not. So, well, thank you, John, for joining me today. And we appreciate having you on this podcast. And that's In the Mix. So
thank you for having me. Appreciate it.
Absolutely.
Cheers.
Well, that's a wrap on today's episode of In the Mix, where we put masonry in the spotlight, block by block, brick by brick. A big thanks to our guest, John Gallup, formerly of Laticrete, now with HydroBlok, for sharing their time and insights with us. If you enjoyed this episode, do us a favor. Click that follow button, leave a quick review, and share it with someone who cares about building smarter and stronger. You can connect with me, Adam Hutchinson, on LinkedIn, and find bonus content from today's episode at masonrymix.com. In the Mix is produced by Espresso Podcasts and hosted by yours truly, Adam Hutchinson. You can find the podcast wherever podcasts are found. Hosting of the podcast is made possible by the Northwest Masonry Institute. Thanks for listening, and as always, stay curious, stay connected, and keep building strong. See you right here next week in the Mix.